So tests about a population proportion. We're going to check the conditions for carrying out a test about a population proportion. If the conditions are met, we're going to conduct a significance test about the population proportion, and then we're going to use a confidence interval to draw a conclusion for a two-sided test about a population proportion. Okay, just two-sided. We'll talk a little bit about one-sided, but not in terms of confidence intervals much. So first of all, conditions for carrying out a significance test: random, normal, and independent. And those are the same as they were in the last chapter. Yay! Don't forget to check your conditions. Yes. So for the normal, it still depends on if we're using a proportion or a mean. If we're testing a proportion or we're testing a mean. In this case, we're testing proportion. The random, okay, it's either a randomized experiment or simple random sample. Okay. Normal for proportions, NP and N times 1 minus P are greater than or equal to 10. And for independent, this either, well, if it's an infinite population, then it's just that the samples have, or that the individuals have to be independent of each other. If it's a finite population, then you also need to be sampling no more than 10% of the population. Okay, so those don't change. Okay? Calculations, also things we've already done. We're going to calculate the test statistic. Now we're going to calculate the p-value. The test statistic is a z-score, or possibly a t-score. With proportions, it's a z-score. Okay, I'm just kind of talking in general here. This is how we carry out a significance test, whether it's proportions or means. Say what? Good. A test statistic measures how far a sample statistic diverges from what we would expect if the null hypothesis were true in standardized units. In other words, it's the number of standard deviations that the sample is from the claim if the claim were true. Number of standard deviations from the number of standard deviations that the sample is from the claim if the claim is true, or the null if the null is true. All right, and how do we calculate a test statistic then? This should not be a surprise. Test statistic is the statistic minus the parameter divided by the standard deviation of the statistic. Now, depending on what we're doing, that could take different forms, but essentially this is the case, right? The statistic could be x bar or it could be p hat. The parameter would be mu or p, and the standard deviation of the statistic is either sigma over the square root of n, or s over the square root of n if we're talking about means really, or square root of p times 1 minus p divided by n. Okay, so those same standard deviation formulas we were talking about before, and those are on your formula sheet, if I remember correctly. The test statistic is basically z or t. They're calculated the same way. And I think this might even be on your formula sheet. How to calculate a test statistic. All right. Benefits of NAFTA. Nationally, about 28% of the U.S. population believes that NAFTA benefits America. A random sample of 48 interstate truck drivers showed that 19 believe that NAFTA benefits America. NAFTA is the North American Free Trade Agreement. Does this indicate the population proportion of interstate truckers who believe NAFTA benefits America is higher than 28%? going to calculate the test statistic, and then we're going to find and interpret the p-value. Now, we're just going to get to the nitty-gritty here, so we're not going to check our conditions and whatnot at this point. I do want to point out the null and the alternative, though, because that's kind of important here. I mean, the conditions are as well, but trust me, the conditions are met. What's the null and the alternative? Okay, p equals 0.28. That's the national average, national percentage. And then our alternative, oh, we can be more specific than that. Yeah, is a higher percentage of truck drivers, right? So the assumption is it's probably not less. Truck drivers in general are probably benefited more by NAFTA than just the general population. And let's identify an alpha value here. We'll let alpha be 0.05. Yeah, either 0.05 or 0.01. I would say if there's not one listed, use 0.05. That's the more common one. And this is not a life or death situation. All right. What's P? Sorry, what's P hat? (19/48), the proportion of truck drivers, right? So our sample of truck drivers, 19 out of 48 of them. 19 divided by 48 gives us I'll just call it 0.40. And so the test statistic. In this case, it would be a z-value because we're talking proportions and it is normal. If you go to means, it's going to be a t-value. Yep. And that's the next section. So we're going to take our statistic, which is 0.4, minus the population parameter, 0.28, divided by standard deviation of the sampling distribution. Now, the standard deviation of the sampling distribution here, we're assuming this to be true. So we use the 0.28. This is a little bit different than we did confidence intervals. Okay. The denominator here is the square root of p times 1 minus p divided by n. Right? When we did confidence intervals, we didn't have any sort of assumption in terms of what the proportion actually was. We had to use the sample statistic. Okay? So we had to use p hat for chapter 8. Okay? But now we have an assumption about what the proportion is supposed to be. So we're using that to calculate our standard deviation. Okay? We assume the claim is true until we can prove otherwise, and so this is our value for p. 0.28 times 0.72 divided by 48. And we're going to calculate that z-value.
You don't really need a test. You don't really need a test.
Correct. Okay. Zach, the only reason you would, well, I'll give you a reason that you might want one. Other than that, they might ask you to calculate it. Because there is a way we can determine whether or not to reject the null based on the test statistic. So here's our test statistic, 1.85. Yeah, but what Zach is saying is really what we're interested in is not technically the test statistic, but the p-value that we get from the test from the z-score. Okay. Do what? know how to calculate it separately. Yeah, and we'll talk about its benefit. There's a way you can use it. Typically, though, the p-value is the more commonly accepted method of going about it. All right, questions? All right. Now, what we want to calculate here is really the probability that the alternate will happen. The probability that p will be greater than 0.28. Okay. That we'll get more truck drivers than 28%. I know we got 40%, but is that far enough? That's what we want to answer here. Now, what's the z-score for? Well, if we're going to calculate this, the probability being greater that the proportion is greater than 28%, that's the same as the probability that the z-score is greater than 1.85. And whether you use greater than or equal to doesn't matter because these are continuous variables. You don't have to worry about the symbol there. If it's over 3, you can reject the null. Or less than -3, you can reject the null. Okay. Yeah. But it doesn't have to be that far. Yeah, like in some cases 2 is going to be far enough. Depends on what your level of significance is. Okay. So for example, probability that z is greater than 1.85. John, calculator or chart? Calculator. Okay. So we're going to find the area to the right of 1.85. So we're going to go distribution, normal CDF. We're going to go from 1.85 to big number. And since I'm using standardized units now, it would be 0 for the mean and 1 for the standard deviation. Going area to the right. Because it's greater than. Yeah. And we should probably sketch that out here. 0.0322. Okay. Yeah, what we're looking at here is, here's my curve. Let me draw a couple of axes here, parallel to each other. Okay. If we're talking in terms of p, then this would be our 0.28. And we're interested in, okay. Oh, wait. I'm sorry, I have the wrong number here. 1.85 didn't correspond to 0.28, it corresponded to our 0.4. Okay. So the probability that our sample would end up with more than 0.4, not p, but p hat. Okay. Well, 0.4 is what is the proportion of truck drivers that. Okay. So that's what we're interested in. So 0.4 is somewhere over here. Correct. So if 28% of truck drivers actually think that NAFTA benefits America, then the probability that we would get a sample with 40% or more would be 3. There's a 3% chance of us getting a sample with 40% or more, saying yes, I like NAFTA. Okay. Yes. Okay. If we're talking in terms of z-scores, right? This was 0, and then this value here are, is the 1.85. And you can talk about it either way. You want to talk about the test statistic, or you want to talk about the raw data. Either way. All right, so find and interpret the p-value, and this is basically what Matt just said. So it's based on the null being true. So if 28% of truck drivers like NAFTA, support NAFTA, however you want to say that, then there is a 3.22% chance of selecting a sample. And really it's a sample of 48, but selecting a sample where at least 40% support NAFTA. I figured with all of the eating that you do all over the place that you had like some sort of candy or something there. Okay. And so if alpha was 0.05, then yeah, we would reject the null because this doesn't happen at least 5% of the time. It's less likely to happen than what we're allowing it to. If alpha we decided to be 0.01, on the other hand, we would have failed to reject the null. Okay? And this is why you decide what alpha is going to be before you start looking at your data. So you're not biased by what sort of data you have.
Okay, so if it was like 5.1%, we would have rejected.
Correct. If the p-value had been greater than 5%, we would not have rejected the null. Because we would say it's, yeah, we would say it's reasonably possible that it would happen. It happens in more than 5% of the samples, so it's reasonably possible that we got one of those samples. It was the 1 out of 20 times that it occurred. Okay. They didn't ask us here to or not, just to find and interpret the p-value. Okay. Don't worry, we'll get to where we put it all together. Okay. But it was important for us to identify the null because we are basing everything on the assumption that the null is true. All right, one sample z-test for proportions. So now let's put it all together. On shows like American Idol, contestants often wonder if there is an advantage to performing last. To investigate this, a random sample of 600 American Idol fans is selected, and they are shown the audition tapes of 12 never-before-seen contestants. For each fan, the order of the 12 videos is randomly determined. Thus, if the order of performances doesn't matter, we would expect approximately 1/12 of the fans to prefer the last contestant they view. In this study, 59 of the 600 fans preferred the last contestant they viewed. Does this data provide convincing evidence that there is an advantage to going last? So let's start by checking our conditions. Random. Be careful. Okay, random sample of 600 fans. Yeah, and it's a randomized experiment. That's maybe the more important part here. By saying it's a randomized experiment, the order is randomized. Okay? By saying it's a randomized experiment, though, we also are implying then that our sample was selected randomly. So it is a randomized experiment. Don't forget that's part of it as well, if it is indeed an experiment. Okay, so there's the random condition. Normal? What's P? P hat. Or, okay, can we do this without calculating P hat? Yeah, NP is going to be 59, right? The number of successes, which is greater than or equal to 10. And N times 1 minus P, 600 minus 59. Number of failures. N minus NP. N being 600, NP being 59. So that would be 541, which is greater than or equal to 10. So yes, it is normal. Independent. Barely? Why do you say barely? Assume at least 6,000 people. I'll write it this way. 600 times 10, which is 6,000 people, are fans of the show. It is last season. It's about time. It's about time. All right. So, what's the null? P equals 1/12. 0.083 repeating. 3. or of reasonably similar quality. Yeah. Right, they're not going to put Henry Who or whatever up there. Yeah. Well, no. It wasn't Henry Who. I forget what his name was, but it was one of those people they put on TV just because it would get laughs.
Like a Hands on the Ground guy
Yes.
that made so much money.
All right. What's the alternative? Are we interested in a specific direction here?
Greater than.
Yeah, that the proportion of fans that like the last person is bigger than a 12th. More than a 12th of the fans like the last person. And alpha, let's go with 0.05. Well, no, this is starting the problem. I know what you mean. Before you do any calculations, right? Okay. So let's calculate the test statistic. Z equals, okay, the proportion from our sample, 59 over 600. I'll just write it as fractions here. 59 over 600 minus 1/12, right? But we're assuming to be the proportion, over the square root of 1/12 times 11/12 divided by 600. Okay. So 59 divided by 600 minus 1 divided by 12 divided by square root of 1/12 times 11/12. Oh, let's make this a little bit simpler here. How about if we just go 11 divided by 144, and then we're going to divide all of that by 600. $1.33. Okay, so we want to find the probability that we would get a sample greater than 59 out of 600, 59 out of 600, which is, yeah, the probability that Z is greater than 1.33.
It's gonna be close.
Yeah, that one was pretty good, wasn't it? All right, so normal CDF. And you could go down to 1.3 and over to 0.03 and then subtract from 1 if you wanted. Distribution, normal CDF, 1.33, comma, just a second. I know you want to go to lunch, so do I.
Yeah.
0, comma 1. 0.0918. Okay, now we're not really done with this problem yet, but we'll pick up there tomorrow.
Yeah.
That's 4%.
I know it.
That's 400.